Konnichiwa, my name is Noman. I am a Flutter engineer based in India. Over the last 3 years, I have been building mobile applications that people rely on in real-world environment. Where connectivity is not always perfect, my focus has been on performance, reliability, and making sure users always have a smooth experience with even in tough conditions. Much of my work has centered on solving problems on network failure, building app that feels dependable regardless of connectivity. Today I'll share lessons and strategies that you can definitely apply in your project, drawn from both successes and hard-earned failures. So today, here is the roadmap for today. First, we'll make the problem of unreliable network very concrete, why it's painful for users and damaging businesses. Then we will introduce the overall solution, a high-level blueprint for offline-first apps. After that, we'll walk step by step through the strategies: local-first design, sync engine, conflict resolution, background tasks, and finally, user experience. Once the strategy is clear, we will talk about how to test these behaviors, monitor them in production, and ensure data security. We'll close with a recap and a checklist you can take home. By the end, you'll have a clear, practical framework. Mobile networks are inherently unreliable. We lose connectivity in tunnels, on flight, and in rural areas where coverage is thin. Even in big cities, Wi-Fi drops or a handoff between towers can cause packet loss and long delays. Bandwidth and latency fluctuate constantly. These are not expectations, they are the norm. Yet many apps are designed as if the network is always strong and stable. That assumption breaks in the real world. If your app depends on perfect connectivity, it's already fragile. Instead, the baseline expectation must be failure. Assume that the network will fail and design around that reality. When apps are not resilient to network failures, the user experience breaks. Imagine filling out a long form only to lose it because the network dropped, or trying to make a payment and getting stuck with an endless loader. These experiences frustrate user and lead them to abandon the task, and in many cases abandon your app. That translates into lost revenue, higher support tickets, poor app store reviews, and long-term retention, and no long-term retention. So network resilience isn't just a technical detail, it directly affects customer satisfaction, business outcome. Building offline first isn't optional anymore, it's a competitive necessity. Let's look at common failure patterns. So many app blocks critical flows on network calls. The user can't proceed until the server responds and they are stuck on an endless loader. Others have no local persistence at all. So once the network dropped, the app is it's useless. You cannot open the app. Some try to fix this with blind retries, but that often duplicates data or corrupt it when multiple retries overlap without a proper caching mechanism. And very few apps handle conflicts across devices. If I edit something on my phone, then offline on my tablet, one update will silently override the other. These patterns are widespread, but they are exactly what makes user lose trust. So let's make this a bit more concrete by looking what actually happens when we put our phone into flight mode. Take WhatsApp for example. You can still open the app, you can scroll through old chats, you can even read your last messages. But the moment you try to receive something, nothing arrives. That's because the network is gone. Still notice how useful it is that the old messages are available. That's caching at work. You can even send messages, but that will be in a pending state. Now think of Instagram. If you already loaded a feed before going offline, You can still scroll through those posts, but try to refresh or open a profile you haven't seen yet. You get nothing new. Again, cache data works, but without connectivity, the app feels limited. And actions like sending a photo or message, most modern apps don't just fail immediately. So instead, they show a small label like pending or a gray tick in WhatsApp. And then they quietly retry in the background when the internet comes back. This is exactly the kind of user experience we want to design for. The app should degrade gracefully, remain functional, and give clear feedback instead of just breaking, similar to WhatsApp's gray tick. So, what are we aiming for? A resilient offline first app has clear characteristics. First, it works fully or partially even when offline. User actions are accepted and stored locally, so they never feel blocked, and the app must be usable without internet. Later, when the network returns, those changes sync automatically and safely. And if there is a conflict, the app handles it gracefully without data loss. And it's the most important part. The user experience includes subtle but clear instructions of sync state. So users know what's happening without being alarmed. So the success is when the app feels fast, trustworthy, and consistent regardless of the quality of network. To achieve this, we need a structured approach, a blueprint. It has 5 key pillars. First, make the local store the source of truth, so you don't have to rely on the server for the data. Second, add an outbox and a sync engine to reliably send and receive changes so that it fetches the latest changes in the background and you don't even notice it. Third, define a conflict resolution strategy so we can safely merge updates across devices. It's very important to manage conflicts. Fourth, schedule background tasks that keep data fresh even when the app is closed, just like Instagram does. And finally, design user experience and observability so both users and developers have visibility into the sync state. With these 5 pieces, the app becomes resilient instead of fragile. Now, moving further, before diving into implementation, we need guiding principles. Start with local first, prioritize local correctness and durability. Design network contacts to be idempotent and safe, so retries don't break the data. Make background work minimal and respectful of battery constraints, because you can't just keep refetching in the background. Conflict resolution must be predictable and explainable. If the user lose their data, you must have a proper explanation how your conflict resolution algorithm works and why they lost the data. They need to understand why. And in the UI, communicate sync state clearly but without creating alarm, just like WhatsApp does with the pending icon, and or just shows the pending icon instead of showing a warning like there is no internet. These principles shape every decision you will make. They ensure you don't just patch problems but build a solid foundation for resilience. Now, let's start with the local first design. Local first design is the foundation. The rule is simple. The UI always reads and writes to local store. First, never wait for the network before showing data or confirming action. When the user makes a change, we persist it locally and mark it as pending state. This ensures instant response and durability even if the network is gone. The user experience stays smooth because the app is interacting with local storage, not the remote servers. This mindset shift from server first to local first is the biggest step towards making your app resilient. So you don't rely on internet to fetch the data. You can cache the data you last used and just open the app and show it, just like Instagram, WhatsApp, and all the other good app does. Now, there are several storage techniques to choose from in Flutter. So the most common is SQLite when you need a relational query or a complex joins. Hive is another great option for simple key value storage and is extremely fast. The other option is Isar. It is highly performance and support reactive query, making it good for dynamic UIs. And the last, ObjectBox. It gives you object graph persistence with some built-in sync capabilities. The right choice always depends on your data model, performance needs, and developer experience. Also, consider factors like encryption, cross-platform support, and the size of your data set. Pick deliberately. This decision shapes your foundation. And here is a short snippet showing the Hive box. Now, to make local storage usable, you need to wrap it in a repository abstraction. That way, the UI only interacts with the repository, not directly with the database. For each record, track metadata like updated at, device ID, and a pending sync flag, which you will use to sync the data. This allows you to know what needs to be synced and where it came from. For more advanced cases, you can track like per field timestamp, and it ensures enabling fine-grained conflict resolution, like the per field timestamp. This structured approach ensures your local storage isn't just a cache, it's a durable, authoritative source of truth that your entire app can trust. So you will never interact with the database directly, you only read and write from the local storage, and the sync engine sends the local storage and to the server and vice versa. Next comes the outbox and the sync engine. The outbox is simply a queue of pending operations, local changes that haven't yet been sent to the server. So basically it's a local storage and the source of truth. The sync engine has two jobs: push those changes up and pull remote changes down. To make this safe, your server API must be idempotent. Use client generated IDs and put semantics so that if a request is retired multiple times, it doesn't create duplicates. The outbox ensures that no local change is lost and it stays in your device, and the sync engine ensures your local storage eventually converges with the server. And here is the short function which shows the functionality of a sync outbox. Now moving further, sync should not happen constantly or wastefully. Like if we sync it on a fixed time interval, we will be just wasting resources. Trigger sync when connectivity is regained, when the app comes back to foreground, or in a periodic background schedule. Batch small operations together to reduce overhead. Don't just fetch the entire app APIs. On the pull side, avoid fetching everything every time. Use delta or incremental sync. Only fetch what changed. Since the successful pull, as everyone is using Git and GitHub, we can take a reference from them. Like we only pull the required changes instead of pulling everything. This approach saves bandwidth, conserves battery, and reduces server load. With the right triggers and patterns, sync become efficient and invisible to the user, just like we don't see anything on WhatsApp, like if they synced anything or not. Now, on the server side, aim for a simple, consistent contract. For example, the client does a put request to source/ID with updated at and device ID included. The server compares the timestamp and keep the latest. If the client is stale and the server responds with the current state, for pulling, provide an endpoint like get resource/changes with a timestamp to fetch only new changes. This contract makes retries safe, like prevents duplication and gives clients an incremental way to stay up to date. It's not fancy, but it's reliable, and reliability is what we need. So here is a small put request with updated at timestamp and a device ID, so that we know which device wrote the last updated values. if we use the same account at multiple devices. Even with careful design, conflicts are inevitable. Two devices might update the same record offline. Strategies vary. So the simplest strategy is last write wins. So we just overwrite everything, and which device wrote the last thing will be stored in the database based on the timestamp. But more advanced will be per field merging, where non-overlapping changes are combined with the timestamp. And for collaborative text, conflict-free replicated data types or CRDTs provide mathematically safe merging. Finally, for critical data, you can surface a resolution UI to the server, similar to what we do in GitHub. Like we resolve the conflicts if it cannot be resolved with the algorithm. The key point is don't ignore conflicts. Decide upfront how you will handle them and make sure the policy is consistent and predictable. It should handle all type of conflicts. So practical conflict resolution. In practice, start simple. For most app, last write wins is enough. If you see frequent loss data, move to per field merges. Keep the newest field value. If both user edit the same field, decide whether to automatically keep the latest or escalate it to a user visible conflict, just like GitHub does. A good pattern is to start with automation for low risk data and involve users only when needed. Suppose if we are building a to-do application, I don't think we need the user to resolve the conflict. If wrote from multiple devices, we can simply override the last write. The point is to keep the data safe without overwhelming users with the complexity. Choose recipes based on your domain and your user tolerance for risk. Now, the background sync. Background sync is about keeping data fresh even when the app is closed. But mobile platforms impose strict limits. Android has doze mode. iOS has very conservative background policies. That means background work must be very, very small, efficient, and respectful to the battery. Jobs should sync only what's necessary and stop if conditions aren't favorable, like low battery or poor connectivity. The goal isn't to keep the app perfectly in sync at all time. It's to catch up enough so the user always feels up to date when they return. So if the connectivity is low or we have low battery, we always prefer to fetch only the minimal data that is required. We don't fetch unnecessary data if the battery is low or the connectivity is low. Now on Android, you can use Work Manager. It provides API to schedule periodic work with constraints like network availability, charging state. But on iOS, background fetch or silent push notifications are the main tool. Best practice is to batch operation, minimize wake up, and apply constraints so sync only happen in good condition. For example, maybe you only sync large payload on Wi-Fi. Always design jobs to be safe if there are delay or skip. Because on mobile you can't rely on precise scheduling. Flexibility is very critical. Retries are a fact of life, but they need to be managed very carefully. Use exponential backoff with jitter to spread out retry attempts. There is a small snippet to show you the retry, how we should be approaching retries with jitter. Use exponential backoffs to spread out retry attempts If a request fails repeatedly, use a circuit breaker. Stop retrying aggressively and wait for a better opportunity. Cap your retry window so the queue doesn't grow unbound. And when something fails persistently, surface it to the user in a subtle way rather than retrying forever. Just showing a snack bar or a small toast like the internet is not stable or something like that works. This keeps your app reliable without draining battery or overwhelming your servers. UX is also important. So we need to make the UX good. Technical correctness isn't enough. The user experience matters equally. Offline first app should feel fast and trustworthy. Optimistic updates are the key. Show the user their action succeeded instantly. Use small subtle indicator to show sync state like a check mark for synced or a small spinner for syncing or a small icon for an error. Avoid alarming alerts. Give user an undo option for destructive actions like deleting a message, and similarly WhatsApp throws a pop-up like just confirm if you want to delete it or not. So if something goes wrong during sync, they can recover. This pattern builds user confidence that app works for them, not against them. You can't ship an offline first app without testing it in an offline condition. That means running flows in airplane mode, throttling network, and testing multi-device conflict. But testing isn't enough. You also need observability in production. Log outbox size, track metrics like sync latency, and set up alerts when retries spike or the queue grows too large. Observability tells you what's happening in the wild, so you can fix issues before they hurt user. Offline first isn't only about resilience in code, it's about visibility in operations. Local storage brings security considerations a lot. Always encrypt data at rest. Using platform provided key management, be careful with personal identifiable information. Store as little as possible and expire data that doesn't need to stay for large. For large media files, implement eviction policies like least recently used so the app doesn't bloat. Remember, devices get lost or stolen. Local first app must balance convenience with strong protection of user data. Security and data management aren't afterthoughts. They are part of making offline first trustworthy. So saving the data locally, like you have to encrypt it because it's accessible if someone get the access to the hardware. And here is a small snippet which shows the Hive cipher which you can use to encrypt your data before saving it to the local storage. Now here is a roadmap to implement like what we explained. So how you put this into practice? So roll it out in phases. Start with phase 1. It will be implement local first design with a repository abstraction where the local storage will be your source of truth and you only read and write from the local storage. And even if you put the app mobile in your flight mode or there is no internet, you don't have to worry about your read and write, and you just the app works seamlessly. Now the phase 2. Phase 2 is add outbox and basic sync. and make your APIs idempotent so that the outbox will sync it with the servers which you stored in the phase 1. Moving to the phase 3, introduce a conflict strategy and UX indicator. The conflict in strategy is very important, but the last right wins in most of the cases. It depends on your case. Now in phase 4, add a background sync, retry strategy and observability, where you just keep an eye on the server and keep syncing whatever is necessary, and the strategy defines what need to be fetched without overloading the server. The phase 5 is harden with encryption, eviction policies and scalability improvements. By phasing, you avoid overwhelming complexity and can deliver incremental values to the user while steadily improving resilience. So I have a case study here. So a couple of years ago, I worked on a field data collection app for agents in rural areas of India, where the internet connectivity was very patchy. The first version of the app was designed in a server first way. Like every form submission had to reach the server before it was considered a valid. Imagine what happened. Agents would travel for hours, visit 10 or 15 households, fill in forms all day, and then lose all the work because the app failed to sync once the signal dropped. It was incredibly frustrating. Not only the data lost, but the trust in the app was lost too. So we went back and redesigned the system in an offline first approach. Now every form was immediately saved locally, so the agent always had a durable copy. The outbox system meant forms were marked as pending and synced automatically later. And for the conflicts resolution, we went with a per field strategy as the data was important. Since two agents might edit different sections of same household, we merged changes field by field using the last right wins. The results were dramatic. The task completion rates improved by nearly 40%. Agents no longer had to redo work, support call dropped, and the overall confidence in the product shoot up. This taught me that offline first isn't just about resilience. It directly impacts productivity, morale, and the long-term success of the app. So when you hear offline first, don't think about the technology. Think about the people using your app in the real world, often in the toughest condition, like mountains, rough terrains, remote locations, etc. So before wrapping up, let's talk about the pitfalls. These are the mistakes I have made myself, or I have seen teams repeat again and again when try to build offline first. First, treating cache as truth. If you just store data locally as a dump cache without metadata like timestamp, device IDs, you will have no way to resolve conflicts later. The cache must be authoritative, not just temporary. Second, retry storms. So many apps blindly retries every failed request. When connectivity flickers, you end up blasting the server, draining battery, and sometimes creating duplicates. A proper retry strategy with backoff is very essential. The third invisible feature. I have seen apps silently drop failed syncs. The user thinks their data is safe, but it never left the device. That's the worst possible outcome. Always make failure visible, even if it's just a small icon. Fourth, over-engineering too early. This is the most common problem. Some teams start with CRDTs or complex merging logic when a simple last write wins would be very fine. Build the simplest thing that works and evolve only when real world users demands it. Fifth, ignoring the user experience. Offline first apps often end up technically correct but confusing. If users see endless spinners or don't understand what spending means, they lose trust. Clear, subtle UX indicators are just as important as the sync logic. These pitfalls sound technical, but the real reason is about trust. Users forgive delays, but they won't forgive losing data. If you avoid these traps, your app will feel dependable, and dependability is what makes users stick around. Here is a quick recap. First, a local first repository based approach in which we will be storing the data locally and it will be our source of truth. The second will be a outbox plus idempotent surface area server APIs to sync the local repository along with the idempotent server, which avoid duplicate data and handle the conflicts. Third will be a clear conflict resolution policy. It's the very important part, like you write your conflict resolution algorithm very, very carefully depending on your app and your use case. Third, a clear conflict resolution policy. Fourth, the background sync with a backoff. Background sync will be very important. If the network fails with the sync, it must have a backoff. Fifth, user experience signals. User experience, like even a small tick mark when the sync succeeded is enough, but it's needed. Thorough testing and telemetry. Thorough testing is really, really important, and telemetry for logging and having a log so that you know where the app crashed. And finally, encryption and cache management. If your app ticks all these boxes, it's offline first, resilient, and ready for the real world. This checklist is your roadmap after today. Thank you so much for your attention. Building offline first apps is challenging, but with a structured strategy, it's achievable and it makes real difference for user. I hope this session has given you clear framework you can apply to your project. Thank you.